just letting it out you to go free.
Welcome to an episode of Iron Science Teacher. My name is Julie Yu. I'm a senior scientist here at the Exploratorium and the director of the Teacher Institute. And today you are going to watch 4 of the Teacher Institute staff compete for the title of Iron Science Teacher. Iron Science Teacher is based on a cult Japanese cooking show, Iron Chef. And in that show, the chefs work to create a meal out of a secret ingredient. In Iron Science Teacher, there is an ingredient that is secret to you, but not to our teachers, and they will work to do a demonstration or a lesson around that secret ingredient, and then you all have the very important job of deciding and voting for your favorite presentation. Can you guys handle that responsibility today? Great. We're here in the webcast studio at the Exploratorium on Pier 15, and this summer, we're very lucky to have a special exhibition here. Just outside the webcast studio, there's an exhibition of strand beasts, which are the dream machines of Theo Janssen. So this season of Iron Science Teacher, which we believe is possibly our 20th season of the show, we are going to take a nod and inspiration from those strand beasts. So are you ready to meet today's contestants? Fantastic. First up, we have senior scientist Paul Doherty, who is co-teaching the high school program of the Teacher Institute. Welcome, Paul. Next up, we have co-director of our leadership program, Zeke Kossover. Not last this time, we have senior educator Eric Muller, who's also co-teaching the High School Institute this summer. And last but not least, we have senior educator Lori Lambertson, who's teaching the Middle School Institute this summer. All 4 of our staff members are working with about 75 teachers here, many of whom who are in the audience, 75 of the finest teachers across the state and country who have come to the Exploratorium this summer to work with us so that we can all work together to improve classroom experiences in their middle and high school classrooms. So hooray for those teachers, please. Are you guys ready to unveil the secret ingredient?
Ready.
If you could make your way. So again, this year, all of our secret ingredients are going to be things that are used in strand beasts. So if you've seen some of the strand beasts, those of you who are in the museum, you've seen that they are made out of everyday materials. And we like to teach using everyday materials. And today, the secret ingredient is going to be the energy, the life source of a strand beast. So what runs a strand beast? Yeah, well, the strand beasts normally live on the beach in Holland, and they're run by the wind. But here in the museum, there's no wind, so we have to use a different secret ingredient. And today, we're going to use that secret ingredient, which is compressed air. So here we have all of these different ways to compress air. Contestants, can you think of something to do with compressed air? You have about 5 minutes to figure it out. Here we go. So contestants, grab what you need, grab as much air as you want. And then we're going to give them each about 5 minutes to prepare their lesson. So let's take a look to see what's going on. What are you going to do? We have Ron here taking a look at Zeke. And Zeke has a giant tube and some mylar. Zeke also has a vacuum pump, which instead of compressing air, takes air away.
I know. It's, something different.
Something different. I think Zeke is, these materials are pretty familiar to me. Zeke became internet famous this year. He had a demo online that reached over 1 million views that he made for Tested. So we know that Zeke is a tested demonstrator, but can he compete against these veteran iron science teacher contestants? We realize that Zeke, this is his 4th competition, but these other folks have well over 20 competitions under their belt. So here we are taking a look at Paul Doherty, who has a variety of bottles and jars. He's wrapping a Coca-Cola in black paper. What could Paul possibly be doing? Paul grabbed the bicycle pump, and so that's one way of compressing air. And let's take a look. He's up on the screen here with the close-up. He's taping the black paper to the Coke bottle. Can you imagine what he's going to do with that? And a bicycle pump? Does that make any sense? Paul is an avid rock climber, and he was climbing just last night, so we can see if he can climb his way to victory today here in Iron Science Teacher. Thanks. I'll be here all season. Next up, we're looking at Lori Lambertson, who took some of the Ziploc bags, which hold air, and it looks like she's taping a straw to them. So perhaps she's going to use some captured air in the bag, just as the Strand Beast used captured air. Fun fact about Lori is she is an avid surfer. So we will see if Lori can hang a perfect 10 and ride her wave to victory. All right, we're moving on to Eric Muller, who is very carefully cutting up a plastic bag that I think he might have grabbed out of the trash. So hopefully this demo won't be too trashy, but Eric is known to turn trash into treasure. Eric's fun fact about Eric is he, in a prior life, was a river rafting guide. He still takes groups down the river. And I might have just unplugged us, sorry. So we will see, you can see Eric's got this giant bag. We'll see if Eric can guide his way to a win here in Iron Science Teacher. Thank you.
Outstanding.
Thank you. He gets an extra point for that. So what could they possibly be doing with compressed air? Contestants, you have about 1 minute to finish up your presentations. Rehearse what you're going to say in your mind. We're going to pick up the music to count down the end of the preparation round. All right, that's it. The end of the demonstration time. Zeke's getting his stuff out of the way, and the contestants will move off, and we will welcome them one by one. Are you guys ready to see what they prepared? All right. First up, he's co-teaching the High School Institute this summer. We have senior scientist Paul Doherty.
So there I was, getting ready to teach physics class, and I had a beverage. We have this beverage right here, it's Coca-Cola. There are other possible beverages, but I'm not going to use that one, it might work. And I was looking at it, like a little light, shed a little light on it here. And when I went to open the beverage, I get a little tipping forward here a little bit much. There we go. When I went to open the beverage, I saw an interesting thing. Whoa! Okay? Right before it erupted in foam, there was just the tiniest cloud in there. So I thought, I just had this beverage, and it's got carbon dioxide in it under pressure, about 2 atmospheres of pressure. And I released that pressure, and there was this little genie, this little mist in there. So I wondered, can I blow that up large enough for you to see? Because that was hard to see. So I thought, okay, so here I have a glass jar, which I've put black paper around the back side of, and I've got water inside of it. And I know a cloud is made of water droplets, perhaps coming from water vapor, so I have some nice water vapor in there, and I have this glove. And this is a little tricky, but I'm going to take the glove. That's right, Ron. I'll move it when I get this set. Whoa. This is a little tricky here. Eric, can you come help? Okay, thank you. You have to stretch the glove. This is like a glove for doing dishes. There we go. And then I thought, okay, I can reach inside of there and pull and reduce the pressure. And I'm not seeing much of a cloud. So I went and, as any science teacher would, I read up on clouds. And it turns out clouds not only require water vapor in the atmosphere, you have to cool it. And when I pull a vacuum, the air inside of there expands and cools. But that's not enough. You need something else called cloud condensation nuclei. I needed to put some nuclei in there, something that could start the cloud process. And the air is just full of dust. I don't know if you've ever looked in your room under the bright sunbeam comes into your room and you see those dust motes dancing in there. So what I am going to do is I'm going to have this match and I'll drop it in there. And that match, if you'll hold it again, Eric, you can see the little wisps of smoke right now. But that smoke is going to go away once I get this back on. Here we go. Lots of hands needed.
Hands on.
Thank you. Hands on. So now I have a jar. It's got water vapor. I stick my hand in the jar and I pull. And I get a cloud. So that's the recipe for a cloud. It has that secret ingredient, cloud condensation nuclei. But reading some more, I discovered that it's because there are no cloud condensation nuclei in that Coca-Cola bottle. I mean, the Coca-Cola company is not going to have smoke in the bottle. So I discovered that there's another way to make a cloud that if you cool it enough, the temperature will drop to minus 40 Celsius. And if I drop to minus 40 Celsius, it's called the homogeneous nucleation temperature. By the way, this thing here is called a fizz keeper. It's really kind of a neat thing. It pressurizes your soda bottles. So I can pump it up, get to a high pressure. Takes a bit of pumping. I can feel the pressure building, feel it building. But what I did to make this work better is I put a little isopropyl alcohol in there. And I don't know if you remember what happens if you rub rubbing alcohol on your skin. It feels cooler. So if instead of using water, you use a little isopropyl alcohol, and I release this pressure, I didn't get much of a cloud in there that time. Try it again. 1, 2, 3, 4. Nope, not much of a cloud. So, since that's the nature of physics, sometimes it doesn't work. I'm going to make it bigger. And this is a wine bottle. And it was real work to prepare for this program. I needed an empty wine bottle. And instead of that tiny, wimpy little pressure, I'm going to go all out. I've got a bicycle pump. I'm really going to pressurize this. What I have in there is just a little bit of wine. And so that's water with a little alcohol. And now I have this cork, and the cork is just connected, a hole through the cork to the bike pump. And so, that's all right, I got it. 1, yeah, if you can hold that, thank you. 1, 2, 3, 4, 5, 6. The ultimate test, are you ready? Cloud. And look at the mist coming out of the top. Welcome to San Francisco. So there you go, there you have it. Water, cloud condensation nuclei, going from high pressure to low pressure makes a cloud. That's why when a low pressure area comes over San Francisco, we have clouds. And when you have a high pressure area, if you have a high pressure area, if you'll hold that again, Julie, watch what happens when a high pressure area comes in. The air heats up and the water drops go away. And that's what we have yesterday in San Francisco. High pressure, clear, low pressure, clouds. And now you know why. So, yay!
That's great! you. Give it up for Paul Doherty, pumping up the crowd. And also showing how compressed air can be used to make fog. I hope you all noticed that Paul used a binder clip as a stand for his flashlight. We had a teacher here once who said, you are not teaching unless you're using binder clips. So Paul, of course, is doing his thing with the binder clips. All right, next up we have Zeke Kossover, who is co-teaching and co-directing our Leadership Institute this summer. Please welcome Zeke.
So I taught high school for 21 years, and one of the things I always wanted as a physics teacher was for the school to buy me a pool table, because there's all sorts of cool physics you can do with the pool table. But the school absolutely refused. They would not let me have one. And I was like, all right, maybe they don't want to have like toys where the students can get at them. But then a couple of years later, they bought a ping pong table. And I was like, why do the kids get to have a ping pong table instead of the pool table? And they came back and they said, well, the difference is that you can throw a pool ball at another kid and hurt that other kid, but a ping pong ball is safe. And I thought to myself, that's a challenge I'll accept. And of course, they actually did have kind of a point, though. And that is, if you throw a pool ball at someone at, say, 30 miles an hour, it hits the other kid at about 30 miles an hour. But if you throw a ping pong ball at another kid at 30 miles an hour, by the time it goes even a short distance, it slows down quite a lot. And that's because, for its size, a ping pong ball has a lot of air resistance. That's the sort of thing that teachers like to say. But they don't like to say the next part, and that is, what is air resistance? And so what air resistance is that when an object's moving through the air, it hits little air molecules, the molecules that make up the air. And every time it hits one of those, it has to push it out of the way. And when it pushes that air molecule out of the way, it loses some of its momentum. To give momentum to air molecules, the ping pong ball has to lose momentum. And because the ping pong ball doesn't start off with very much momentum because, well, it doesn't weigh very much, so it doesn't have much momentum even if it's moving fast, then it gives away a whole bunch of momentum along the way. And because it's big, it runs into lots of air molecules, and so those two things work together to make ping pong balls slow down very quickly. When I was a kid, we used to play sting each other with ping pong balls. We try to hit it as hard as you can, and the wounds were not satisfactory for teenage boys. But the reason why you run into so many air molecules is because this air that we are in right now is actually compressed air. We don't usually think about this air as being compressed, but it actually is compressed quite a lot. If we went up to a higher altitude, the air would be less compressed and it's hard to breathe. And so my thought was that if the problem with moving a ping pong ball through the air quickly is that it runs into too many air molecules, then we should get rid of some of those air molecules. We should decompress this air some, and then the ping pong ball could go faster. And that's the point of this apparatus. So this is a big piece of PVC, and it's connected to a vacuum pump. And what I'm going to do right now is I'm going to seal up I'm going to put a ping pong ball in. And then I'm going to seal up this pipe. So this is Mylar. It's the same stuff they make balloons out of. And we're going to seal the ends. And now I'll seal the other end.
So Zeke has trapped a ping pong ball in a tube, and he's capping the ends by sealing Mylar on both sides.
And then I'm going to give myself a target. That's going to be this aluminum can, because I have bad thoughts about that aluminum can. All right, so what's going to happen in a moment is I'm going to turn on the vacuum pump. It's going to draw the air out of the tube. The air pressure in the tube will get lower and lower. Then I'm going to puncture the end. Remember, I said this is compressed air. It's going to push on the ping pong ball. So the ping pong ball is about 3 grams. It's about 3 square inches of space. So about 45 pounds is going to push on 3 grams. Those are mixed units, but you can figure it out. It's going to push on that ping pong ball. The ping pong ball is going to accelerate down the tube. It's going to get faster and faster. And because there's almost no air on the other side of it, the ping pong ball can get going really fast. It can leave the end of the tube near the speed of sound. I feel bad for this can, just a little. All right. Luckily, this is a blast shield. It's a bulletproof shield, so everyone over there will be safe. There will be one problem, though, and that is it will be loud. So you all are going to want to put your hands over your ears. Okay, you don't have to do it quite yet, but I'll give you a warning. You'll put your hands over your ears like this. This way works the best. You'll know that we're close because I'll turn this valve, which will keep the air from rushing back into the vacuum pump. And you'll see me feeling on the vacuum pump. I'm feeling the exhaust until there's no more air coming out. And it takes about 30 seconds. I'll put my hands over your ears. Now, there is one other problem, and that is that the Exploratorium has lots of people in it who are not right here. And they might be worried about a loud sound. So we need to warn them that that's going to happen. So we're going to count down. We're going to go 3, 2, 1. They won't know what's going on. They'll just know something's going to happen. And that way they probably won't, go to the bathroom in their pants, because they'll be ready for something to happen. Are you all ready to do this? So Ron and I are going to put on earmuffs because we can't cover our ears. Our hands will be busy. But you'll all be fine just putting your hands over your ears. Three, 2, 1.
Oh my goodness.
Challenge fulfilled.
All right, let's give it up for Zeke Kossover, who made an Illume can find spirituality by making it holy. Thanks, Zeke. All right, next up we have a co-teacher of the High School Institute and a senior educator here at the Exploratorium. Please welcome Eric Muller.
I'm going to pull this back. Just back a little bit over here.
Eric needs a little more room.
Good on that? Yeah, we're good. I got to follow that? Okay. I'm under a lot of pressure here. A lot of pressure. Anybody have any idea how much pressure I'm under? 1 atmosphere. Thank you very much, afternoon elected from yesterday. 1 atmosphere of pressure. So I don't know how I'm going to follow that, and actually, I'm probably just going to make a mess here, so I'm just going to pull a vacuum cleaner out right at the start of this. And I'll get my garbage bag ready. Clean up too. But I'm going to need a volunteer. Anybody want to volunteer? You in the back. You interested in volunteering? Elizabeth, come forward. We've never met before, have we? Random person in the audience.
Random volunteer. Can you tell folks your name?
Elizabeth.
And Elizabeth, what brings you to the Exploratorium here today?
I'm a high school biology teacher, so I'm here for the Summer Institute.
Wonderful. Where do you teach?
San Mateo High School.
There you go. Let's give it up for San Mateo High. Thank you, Elizabeth, for trusting your life in Eric's hands.
Can you do me a favor, Elizabeth? Can you take your shoes off? Sure. Okay. So I'm going to have you, number one, trust me. And number two, I'm going to have to get you into this bag right here. Okay. Oh, by the way, as far as Zeke's activity goes, don't try that at home. As far as my activity goes, don't try this at home. You ready? Okay. Hop in the bag. And what I want you to do is I want you to get in the bag and you're going to cross your legs when you get in, okay?
Okay.
Yeah. And then you can sit on the carpet over there. And there you go. There you go. Can I get another volunteer? Hey, Dawn. We've never met before either, have we? Okay. And can you do me a favor, Elizabeth? Can you scoot forward as far as you can?
While Eric's situating Elizabeth, can you tell us your name and why you're here today?
I am also here for the Teacher Institute. My name is Dawn. I'm from San Diego. Came up for
San
it.
Diego?
Where and what do you teach, Dawn?
I teach at High Tech High International. It's in Point Loma. And what was your other question? Oh, I teach physics, 9th grade.
All right, so let's hear for Dawn from High Tech High.
Very good. You want to do me a favor, Dawn? You want to hang out over here. There's a switch on that side. I'll let you know when to flip it. I have Elizabeth in the bag, and I'm going to use air pressure to compress Elizabeth. And I'll explain that later. But let's do the demo first. So what I'm going to do is I'm going to hand Elizabeth this hose. And let me make sure this is put on the right way. Yep. And I'm going to put this over her shoulder. And she's going to put it right in between her crossed legs. And when she does that, I want you to hold this so that you have holes right here on the side so that your clothing doesn't get sucked in and the bag doesn't get sucked in. Does that make sense? Right in the middle. Ooh, it'll come on this side. Okay? So make sure your hand doesn't get sucked in either. Okay? Does that make sense?
I think so.
Okay. So what I'm going to do is I'm going to move this bag up just a little bit, and I'm going to use her neck to make a gasket. Not a casket, a gasket. And what we're going to do is turn the vacuum cleaner on, and we're going to remove some of the air inside of there, and let's see what happens. You ready? Go ahead. Keep going, keep going, keep going. How does it feel in there?
Not good.
Not good? Very good. Thumbs up. Okay, you can turn it off now. So it's always important to have somebody on the switch over here. Can you describe it over there?
Like I was getting squeezed.
Like you were getting squeezed, like you can press inside the bag?
Yeah.
So let me tell you about what's going on. So it turns out we are under an ocean of air over here. We have about 15 pounds per square inch of pressure on every single square inch on this bag here. I'm going to use English system. And hey, Paul, can you come on over here? And actually, Dawn, you want to hold that up for me just like that? Okay. So thank you. So on one side, we have the pressure hitting the bag. Go ahead. And the molecules are tapping on this thing and tapping on it. But if I remove some of the pressure inside of there, watch what happens. See how the bag goes in? Excellent. Thank you very much, Paul. Give Paul Doherty a big hand.
Look at that good sportsmanship.
So we're going to remove some air again. But before I do that, just so you know, I got something sad to tell you. One of these days, I'm not going to be around. And so I want you to inherit $1 from me. Okay? And when I'm not around, Julie, you're going to give it to her. So you're going to inherit that $1. You'll know. You'll know when the time comes. And so you will inherit my money. And so what we're going to do is we're going to squeeze this again. Go ahead. Ladies and gentlemen, my compressed air. Get it? Inheritance. Thank you very much.
All right. Thanks for the tip, Eric.
She gets it.
Oh, yeah. Thank you so much, Elizabeth and Dawn, for volunteering.
My demise.
We will see if the other contestants can bring about your demise. But let's give it up one more time for Eric Muller, Under Pressure. And last but not least, she's co-teaching the Middle School Institute this summer. Please welcome Lori Lambertson.
Thank you. Hi, everybody. Welcome to Iron Science Teacher. So Eric was talking about that we live underneath all of this air, and these air molecules are moving randomly about, and they crash into things, and when they crash into things, they exert a little bit of pressure. They're really, really, really small, and so they exert a really small amount of pressure. But more and more and more air molecules, like fantastically high numbers of them, can actually we sum all those little collisions and the forces so that we can actually exert quite a bit of pressure using air. And so maybe you saw earlier that I was trying to blow up a bag with air. And if I blow up a bag, I've got a certain number of molecules in here, and they're all moving around randomly, and they're crashing into the side of the bag and exerting some pressure on it. And I kind of want to do a little model with some volunteers using this square that I drew on the floor. So my bag kind of has like a square outside perimeter. And I made sort of a square here. So if I could have like 4 volunteers to come up and walk around in my square for me, that'd be great. I see 2 over here. How about the 2 of you as well? And guess what? I'm going to need a few more, so you can be in round 2. Come on up, the 4 that I identified. Come on over here. So the air that we breathe, what's it mostly made out of? Nitrogen, yes. About 78% nitrogen. And what else is in the air that we breathe? Oxygen, yeah, about 21% oxygen. So when we inhale, we're inhaling mostly nitrogen, some oxygen, and then 1% other stuff. When we exhale, like we need that oxygen. So when we exhale, which one do you think decreases? Yeah, oxygen. And so we take in that oxygen and we give off carbon dioxide. So you guys are going to be exhaled air, like I blew it in the bag. So you get to be some of the nitrogen. So as we exhale, about 78% of nitrogen is still exhaled. Can you put that over your neck for me? So I've got 3 nitrogen molecules, and I got 1 oxygen molecule. You get to be oxygen for me today. Can you guys all step inside the square? So you guys are the air molecules inside the bag, and you guys are going to do some collisions for me. And you can't go outside the bag. Not with each other, just with the edge. Sorry. So the collisions are going to happen around the edge of this bag. And so as you walk, when you come to one of these blue lines, I want you to say beep, and then turn around and go a different direction. Is it clear what you're going to do? Okay, please don't run into each other. So you can't move super fast. But whenever you hit one of the blue lines, I want you can't go outside the bag, because you're like one of the air molecules inside this bag right now. And this bag's sealed, so you can't get out. But we need to hear those beeps nice and loudly, all right? So I want you guys to just listen to kind of the rate of beeping. Is it clear what you guys are doing? All right, go at it. Beep. Loud beeps. Beep. Yell. Excellent. What a great job of random air molecule movement. Okay, molecules. Molecules, stop for a moment. So when I blow air into this bag, I get a certain amount of molecules. But air has space. There's space between these molecules. So even when the bag looks like it's pretty much done being inflated, I can get a little bit more in there. Because air's compressible. So let's see what happens when I add more molecules. Can I have 4 more molecules join me? You wanted to come up before? Yeah, I need 3 more molecules. Can you join another molecule? Can I get 2 more molecules? Come on up. Are you a molecule? Do you want to be a molecule? You too can be a molecule. I got 1 more in the back. Come on up, molecule. So, we still got some, can you put this around your neck, please? You're still going to be nitrogen. Still, most of our exhaled air is nitrogen. You too are nitrogen. You can be some more oxygen, and guess what? Eventually we do get some carbon dioxide in that exhaled air. Did I run out? I have 1 more for you. You bet I do. You're going to be some more oxygen too, because we don't use all the oxygen we inhale. All right. Now, you guys saw my new molecules. Did you see what we did before? Yeah. Okay, so you know what to do? When you hit a blue line, you have to turn around and say beep. Don't run into each other. Okay. All right. We've got some eager molecules. Okay, molecules, start moving and really yell when you hit a blue line. Beep. Listen to the rate change. We got a lot more going on now. Great. You guys can stop. What a great demonstration.
Wonderful. Thank you.
Thank you, molecules. You can go back and you can keep your nice signs. Yeah, you can keep them. Why not? Gift to the Exploratorium. So, what can I do with that? I can add more air to the bag and increase the pressure in the bag, because more collisions against the side of the bag means I have more force, and more force means more pressure, because pressure is force over an area. And so I now have a way to use my bag to store energy, because compressed air has potential energy. And this is how the strand beasts work. Theo Janssen invented a system for the strand beasts that takes wind and pumps it into 2-liter bottles. Those 2-liter bottles, like this bag, when it's inflated, have a fixed volume, but we can pump more air into it because air is compressible, and compressed air has the potential to do work. So we're going to see what kind of work my airbags can do. I have another set of volunteers. Can you come up, please? And oh yeah, can you come up, please? Oh, and you in the back, and you. I have some volunteers. And first we're going to move out this table. Thank you. Have I ever met any of you before? No. These volunteers picked at random from the Middle School Summer Institute. So these are teachers that are here doing science with us during the summer, and we are delighted to have them here. I don't need any of this stuff now. And so, the same kind of bag that I showed you earlier is now put between 2 tables, and there's a straw there. And so I hear people saying, "No way. You don't even know what we're going to do." So my volunteers, have I ever met any of you before? Okay, my volunteers, they're going to increase the amount of air in these bags. So first, of course, the bag's volume is going to change because they're flat now. But at some point, the volume will be fixed, and they're still going to be able to get a little bit more air in there. So now I've got, my air is going to do some work. It has potential energy. And I'm going to stand, I think I'll just sit. I'm going to sit on top of this table, and we're going to see if the power of that potential energy, if it can lift me. They're going to blow into these bags. What do you think? All right, volunteers, take your positions.
What do you guys think? Air can move a strand beast, but can air lift Lori?
So my weight plus the weight of this table is about 160 pounds. Now, I can't lift 160 pounds, but can your lungs? What do you think? So, elevate me! Yes, and here I go. All right. You guys can let me down now. I have been elevated. I feel kind of elevated. Yeah? All right. You can let me down. Thank you, volunteers.
Thank you so much, elevators.
Like what Zeke and Eric did, this is not something we do at home. All right. I'm done. That's
All
it.
right,
That was
let's
it.
hear
I was
for Lori
levitated.
Lambertson. Did she elevate herself high enough to win your esteem of voting her the Iron Science teacher? So next up, the work turns to you. We're going to ask you to vote by the strength of your applause for your favorite demonstration today, and that favorite demonstration is going to be crowned the winner of Iron Science teacher. You guys ready for that? Yeah. Okay, we're going to bring out the contestants, and I'm going to remind you what they did, and then we're going to vote. So here again are your lovely contestants for today. First, we had Paul Doherty. Remember, Paul did, he used compressed air to make fog in a bottle. Next up, we had Zeke Kossover, who decompressed air to show how much compression there normally is and used a ping pong ball to blow up an aluminum can. Third up, we had Eric Muller, who showed how much pressure regular air has when you just remove a few air molecules in a trash bag. We'll see if Eric has to throw himself away after this. And last up, we had Lori Lambertson, who used the power of air to elevate herself. Okay, so I'm going to use my trusty sound level meter because I don't trust myself. And by the strength of your applause, let me know if you prefer the demonstration from Paul Doherty. How about Zeke Kossover? Let's hear it for Eric Muller. And how about Lori Lambertson? I think it's pretty clear she floated her way to the top. The winner of today's Iron Science Teacher is Lori Lambertson. All right, thanks to our contestants. Thank you all for coming. Thanks to those of us joining online. We will be back again next week, next Friday at noon. Please come see our next 4 contestants. They will be teachers who are participating in the Teacher Institute this year, and they will get to be cheered for their teaching. When does that happen? Please join us. Have a great day, folks. Thanks for coming to the Exploratorium.